So hello everyone, now welcome back to my channel JBR online classes, and in this video I'm going to start from sum number 11 of exercise 5.1. This is a third part from this exercise. For the previous one, please check the description box, the link will be there. Okay, so here if fx, the function here, tan 3x by kx when x not equal to 0 and 1 when x equal to 0. Find k so that the function f may be continuous at x equal to 0. So here sum number 11 is as same as sum number 10, the previous one. So very easy. So as here limit x tends to 0, fx equal to limit x tends to 0, tan 3x by kx. Okay, now 1 by k is the constant part, so 1 by k limit x tends to 0, this one here tan 3x. Now instead of x, write down here 3x, and to adjust this 3 you can multiply here 3. So 1 by k limit x tends to 0, this one here tan 3x by 3x, you can write down 3 as constant, so outside. So this one equal to here 1, because limit x tends to 0, tan theta by theta equal to 1. So here you can write down 3 by k. Okay, and here f0, that one equal to 1. So if f is continuous, then definitely 3 by k equal to 1. So k equal to here 3 as your answer. Okay, it's a very easy problem. Okay, now the next one. So next one here, sum number 12. In sum number 12, here is the function f defined by fx equal to tan x, okay, at x equal to pi by 2. So here in 2, as here is the function f defined by fx equal to here tan x, continuous at x equal to pi by 2. So for the right continuous, x tends to pi by 2 plus fx equal to limit x tends to pi by 2 plus tan x. Okay, and that one equal to minus infinity. Now for limit x tends to pi by 2 minus fx, so limit x tends to pi by 2 minus tan x, and that one equal to plus infinity. Okay, so that means here the right continuous is not equal to the left continuous. Okay, so fx is discontinuous, at x equal to pi by 2. Okay, now the next one, sum number 13. Here in 13 is the function f defined if x is equal to mod x continuous at x equal to 0. Okay, so as here mod x, so mod x means for the x such that x greater than 0, 0 when x equal to 0, and minus x when x less than 0. Okay, so for the left continuous, x tends to 0 minus fx. So as here 0 minus, so that will be minus x. So limit x tends to 0 minus x, and that one equal to 0. Now for the right continuous, limit x tends to 0 plus fx. So greater than 0, 0 plus means, so limit x tends to 0 plus, that one equal to here only x, and that one equal to also 0. And for f0, that one equal to 0. So definitely f is continuous at the point x equal to 0. Clear? Now for the 14 here, fx equal to mod x minus 1. Okay, so that means here the first one x minus 1 when x greater than 1, then minus x minus 1 when x less than 1, and 0 when x equal to 1. Okay, so now for the left continuous, sorry, it's 1 minus, not the 0 minus, it's 1 minus fx. So limit x tends to 1 minus 1 minus means less than 1, so minus x minus 1. Okay, minus x minus 1. So that one equal to here minus 1 minus 1, and that one equal to 0. Now limit x tends to 1 plus fx. So limit x tends to 1 plus greater than 1, that means x minus 1, and again 1 minus 1, that one equal to also 0. Okay, now just check for f1. So f1 equal to here x minus 1, that means again 1 minus 1, and that one equal to also 0. So definitely f is continuous at x equal to 1. Okay, at x equal to 1. Now next, sum number 15. So sum number 15 is as same as the previous one. I hope you can solve this one. Okay, now let's move on to sum number 16. Examine the following function for continuity at the indicated points. So first one, if x equal to here x square minus x square when x greater than equal to 0, and minus x when x less than 0 at the point x equal to 0. So let x limit x tends to 0 minus. So for the left continuous, 0 minus means less than 0, so limit x tends to 0 minus, that is minus x. Okay, and that one equal to 0. Now limit x tends to 0 plus fx, that means greater than 0. So limit x tends to 0 plus here x square, 0 square means again 0. And next one f0. So f0 means x square. So x square means 0 square. So that one equal to also 0. So this one also continuous at x equal to 0. Okay. Now next one, number 16 2. 16 2, here you have fx, and here 5x minus 4 when x less than 1, and 4x square minus 3x when x greater than equal to 1. Okay, so for this one, limit x tends to 1 minus 1 minus fx means here x less than 1, so limit x tends to 1 minus 5x minus 4. Okay, 1 minus 5x minus 4, so that one equal to 5 minus 4, and it's 1. Now limit x tends to 1 plus, so 1 plus fx means limit x tends to 1 plus here 4x square minus 3x. So 4x square means only 4 minus 3, that one equal to also 1. Now for f1 again 4x square, so 4 into 1 minus 3 again 1. So definitely f is continuous at x equal to 1. Okay. Sum number 17 is as same as sum number 16. So now let's move on to sum number 18. In sum number 18, examine the following function R for the continuity. So again here, if x equal to x by mod x when x not equal to 0, and 0 when x equal to 0. Okay, 0 when x equal to 0. Now first check limit x tends to 0 minus. For the left continuous, fx, so limit x tends to 0 minus here x by mod x. So limit x tends to 0 minus x by minus x, and that is minus 1. For the right continuous, limit x tends to 0 plus fx. So limit x tends to 0 plus x by mod x, and for this one here only limit x tends to 0 plus x by x, and that one equal to 1. Okay, so that means the left continuous is not equal to with the right continuous. So here f is discontinuous at the point x equal to 0. Okay, similarly you can solve the next part. Now next, sum number 19. Sum number 19, here you have total 3 sums. Okay, so here I'm going to solve the second one. Second one, fx equal to here sine 2x by sine 3x when x not equal to 0, and after that here sine only 2 when x equal to 0. So for this one, here limit x tends to 0 fx, okay, that one equal to limit x tends to 0, here sine 2x by sine 3x. So here you can apply the formula limit x tends to 0. Here you can write down sine 2x by 2x. To adjust this 2x, multiply 2x, and this one limit x tends to 0, sine 3x by 3x, and again multiply 3x. So here x cancel out, 2 by 3, and limit sine 2x by 2x, that one equal to 1, and the lower one also 1. So that is 2 by 3. Okay, that is 2 by 3. Now next one for f0. So f0, that one equal to here f0 equal to 2, it's given. So as here the limit x tends to 0, fx equal to 2 by 3, but f0 equal to 2, that means not equal. So this one also discontinuous at the point x equal to 0. Okay, discontinuous at the point x equal to 0. Now the third one, sum number 3. Okay, so in sum number 3, here you have cos 3x minus cos x by x square. Okay, so first write it down. If x equal to cos 3x minus cos x divided by here x square when x not equal to 0, and minus 4 when x equal to 0. Is it clear? Okay, so as here for f0, that will equal to minus 4. So now limit x tends to 0, here cos 3x, okay, cos 3x, so cos 3x minus cos x by x square. Okay, cos 3x minus cos x by x square. So do one thing here. As you have cos 3x, you know the formula, cos 3x equal to 4 cos cube x minus 3 cos x. Okay, 4 cos cube x minus 3 cos x. So instead of here cos 3x, we can write down here 4 cos cube x and minus 3 cos x, and this one 1 cos x. So minus 3 minus 1, that one equal to 4 cos x. Okay, so this one equal to here 4 cos x, then divided by x square. So now limit x tends to 0. If you common 4 cos x, so it will be here cos square x minus 1, and divide it by x square. So now here limit x tends to 0, here 4 cos x and cos square x minus 1, that one equal to here minus sine square x divided by x square. Okay, so now limit x tends to 0, here 4 cos x, and this one limit x tends to 0, sine x by x whole square. Okay, so for the first one, as here minus, so put down here minus also. So it's minus 4 because limit x tends to 0 cos x, that one equal to 1, and limit x tends to 0 sin x by x, that one equal to also 1. So minus 4, that one equal to your value. So for limit x tends to 0 fx, that one equal to minus 4, and for f0, that one equal to also minus 4. So that means here f is continuous. Okay, f is continuous at x equal to 0. Now next one, sum number 20. In sum number 20, you have total 7 sums. So here the first one, fx equal to here x square minus 25 divided by x minus 5 when x not equal to 5, and k when x equal to 5 is continuous at x equal to 5. Then find the value of k. Okay, so all sum are similar kind of sum. So if x tends to 5, then here x square minus 25 divided by x minus 5. Now x square minus 25, that means x square minus 5 square. So here you can apply the formula a square minus b square. So this one will be here x plus 5 and then x minus 5 divided by x minus 5. So limit x tends to 5 means 5 plus 5 and that one equal to 10. Okay, so now here if x is continuous at x equal to 5, so k equal to 10, that is your answer. Now for number two, find the values of k so that the function fx, again here fx and here kx plus 1 if x less than equal to 5 and 3x minus 5 if x greater than 5, continuous at x equal to 5. So for the left continuous x less than minus 5 fx, for the left less than minus 5, that means kx plus 1, so that is equal to 5k plus 1. And for the right continuous, limit x tends to 5 plus 3x minus 5, so 15 minus 5, that one equal to here 10. Now as here fx is continuous, so definitely here the value 10 is equal to with 5k plus 1. So that means here k equal to 9 by 5. Okay, k equal to 9 by 5. So now the next one, sum number 3 and 4, a similar kind of problem. So move on to sum number 4. Here fx equal to here tan 5x by sine 2x. Okay, tan 5x by sine 2x when x not equal to 0 and k when x equal to 0, continuous at x equal to 0. You have to find out the value of k. So again it's same for here tan 5x by 5x, to adjust this 5x multiply with 5x, and this one sine 2x by 2x into 2x. So x cancel out, this one equal to 5 by 2, and the upper one limit x tends to 0, tan 5x by 5x, that one equal to 1, lower one also 1. So 5 by 2, and as here continuous, so k is equal to with 5 by 2. Okay, the easy one. Now next one, this one here, sum number this is sum number 5. Okay, not the 4, this is sum number 5. Now next one, sum number 6. Sum number 6 here, fx equal to again 1 minus cos 4x divided by 8x square. Okay, when x not equal to 0 and k when x equal to 0 is continuous at x equal to 0, you have to find out the value of k. Again similar kind of problem. So x tends to 0, here 1 minus cos 4x divided by x is 8x square. So limit x tends to 0. Now 1 minus cos 4x, you can apply the formula 2 sine square 2x divided by 8x square. Okay, so now for this one, 2 cancel out with 8, it's 4. So again you can write down limit x tends to 0, here sine 2x and then by 2x, its whole square. Okay, sine 2x by 2 is whole square, so that one equal to here 1, and as here it's continuous, so definitely k equal to 1, that is your answer. Okay, so now the next one, sum number 21. In sum number 21 here, if x and here ax plus 1 when x less than equal to 3, bx plus 3 when x greater than 3, and it's continuous at x equal to 3. So for the left continuous, limit x tends to 3 minus, it's here ax plus 1, that means 3a plus 1. For the right continuous, limit x tends to 3 plus bx plus 1, that means 3b plus 1. Okay, and for f3, this one equal to 3a plus 1. So as here fx, the given function is continuous at x equal to 3, so definitely 3a plus 1 is equal to with 3b plus here 3b plus 3. Okay, 3b plus 3, sorry, this one here 3b plus 3, not the 1. So from this one 3a minus 3b equal to 2. Okay, 3a minus 3b equal to 2. This one is the relationship between the a and b when the function is continuous at x equal to 3. Clear? Okay, now the next one here, suppose some number 23. Okay, some number 23. Now in sum number 23, here the first one, limit x tends to 0, and here cube root of 1 plus x minus 1 divided by x. So write down here limit x tends to 0. Now cube root means 1 plus x whole to the power 1 by 3 minus 1 divided by x. Is it clear? Okay. Now limit x tends to 0. 1 by x whole to the power 3. Okay, 1 by x whole to the power 1 by 3, not 3. 1 by x whole to the power 1 by 3 minus 1 by x. So we can write down this one as 1 plus x by 3. Then here 1 by 3, 1 by 3 minus 1, 1 by 3 minus 1, here the x square by 2 factorial, and then up to infinity, after that minus 1, and then divided by x. Okay, so here limit x tends to 0, here 1 by 3 if x common. Okay, 1 by 3, because here 1 1 cancel out, so this one equal to again 1 by 3, and here 1 by 3 minus 1 x only by 2 factorial, and then dot 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 up to infinity by x. Now if x equal to 0, so your answer will be here 1 by 3, because here x cancel out, so 1 by 3, that is the value. Okay, and for if, okay, for if 0, this one equal to also 1 by 3. Okay, so that means here if is continuous at x equal to 0. F is continuous at x equal to 0. Okay, now the next one, sum number 25, and this is the last sum for this video. So guys, if you like my video, please share this video and please subscribe my channel. Okay, so here show that the function if x is mod x and then mod x minus 1, where x belongs to R, is continuous at x equal to 0 and x equal to 1. Okay, so we can write down here fx for minus x minus 1 when x less than 0, x minus 1, okay, when 0 less than x less than 1, and x plus x minus 1 when x greater than equal to 1. And again, so fx equal to here minus 2x plus 1 when x less than 0, 1 when 0 less than equal to x less than 1. Okay, and this one 2x minus 1 when x greater than equal to 1. सो पहले हम यहाँ पर प्रूव करेंगे कंटिन्यूटी एट x इक्वल टू 0. x इक्वल टू 0 में कंटिन्यूटी यहाँ पर शो करेंगे. चलिए पहले यहाँ पर लिमिट x टेंस टू 0 माइनस लेते हैं. सो 0 माइनस लेस देन 0, यहाँ पर फंक्शन होगा माइनस 2x प्लस 1. सो 0 दैट इज 1 इक्वल टू 1. अब राइट साइड में राइट कंटिन्यूअस 0 प्लस मीन्स ग्रेटर देन इक्वल टू 1. ओके, सॉरी 0 प्लस मीन्स दिस वन. ओके, क्योंकि 0 से थोड़ा ज्यादा, सो लेस देन x लेस देन 1, सो यहाँ पर हो जाएगा सो यहाँ पर हो जाएगा डायरेक्ट 1. ओके, सो दैट वन इक्वल टू 1. सो नाउ if 0 का वैल्यू निकालेंगे, if 0 का वैल्यू भी 1, तो इसका मतलब 0 के लिए कंटिन्यूअस हो गया. अब 1 के लिए देखेंगे. सो लिमिट x टेंस टू 1 माइनस में लेस देन 1, सो यहाँ पर 1 आ जाएगा. सो इसका वैल्यू भी 1 हो गया. नाउ लिमिट x टेंड्स टू 1 प्लस दैट मीन ग्रेटर देन इक्वल टू 1, सो 2x माइनस 1 दैट वन इक्वल टू ऑल्सो 1. और f1 के लिए ओके f1 के लिए भी यहाँ पर 1 होगा. सो इसीलिए यहाँ पर भी कंटिन्यूअस शो कर रहा है फॉर x इक्वल टू 1.